Let's look at MATLAB's workspace variables, strings, and certain functions. The command CLC clears the command window. So the view of the current command window is cleared when CLC is used. The command clear clears the workspace variables. So the workspace variables are removed and the workspace cleared when the clear command is used. The command var returns the list of installed components and the version of MATLAB's toolboxes. The entire list is returned when the var command is used. The command calendar returns the data corresponding to the current year and month. So this is May 2020. So if I say calendar without arguments, then it takes the default, which is the current month and date, month and year, and returns the data of the current year and month. If calendar is used in this syntax, that is year and month, it returns the data corresponding to the corresponding year and month. So I have asked May 2000, so this is the data corresponding to May 2000. Calendar also happens to be a financial toolbox function. So it has a wide variety of commands available in financial toolbox together with calendar. So when financial toolbox is not installed, those functions are not available for use with calendar command. The commands tick and talk are MATLAB's stopwatch timers. So if there is an event before tick and talk, these two commands measure the time consumed by the event. So tick talk with no event in between returns a very tiny value, as I'm showing here. When there is a small event, I'm showing a small event that is invoking the ran command just one time. So it has taken these many seconds, 0.024 seconds. So we could have a large program, for instance, between the tick and talk commands, and these two compute or measure the time the event consumes. The command clock returns a vector of size 1/6. The entries of the vector are the year, month, day, hour, minute, and second in that order. So note also that the 10 to the 3 is pulled out of that vector. So each of the entries needs to be multiplied with 10 to the 3 to see the corresponding actual value. So the month is 0.005 into 10 to the 3, which is 5. So 5th month it is. Day is 7th, and so on. 2020 is the year, and so on. M equal to magic 4 creates the MATLAB workspace variable called M, and it carries the matrix data of the magic square of size 4/4. So this is a magic square of size 4/4 returned to the workspace variable M. R equal to ran332 creates a three-dimensional matrix of size 3/3/2. It's a random matrix. So uniform random variable is the default random number generator. So I have the R matrix, 3/3/2 matrix with these entries. So the third dimension is stacking up the planar matrices one on top of the other. So since it's 2 in the third dimension, so these two matrices are one on top of the other for this structure, or is structured that way. We could have matrices of 4 dimensions also n dimensions. So the matrices are accordingly structured. The command whos returns the current variables, their sizes, the memory size, and the class of the variable. So the command save with name followed by mat saves the entire variables to current data.mat. So the different data structures, M is a 4/4 matrix, R is a 3-dimensional matrix. We could have strings, we could have figure objects, we could have a variety of structures, and all of them get saved to current data.mat. All of the formats, all data gets saved in this once the save command is used. Now I have cleared the variables, after which when I invoke whos, I don't see any variables because all of them have been cleared. Now I can get the variables back by using the load command. Load current data.mat brings all the variables back to the command window. And when I say who's next, this time if I say who's, I get back all the variables. I see all the variables again, the same view in the previous time that I used who's. The T is a vector consisting of several small string objects. Hey is a string object consisting of 4 characters with a space. How space is another string object, and so on. So T concatenates all of them and forms this compound string made up of the smaller strings. They all get added up, concatenated, and returned to the T variable. If AA is another string, as shown here, the string is indexed in the usual way. So AA's second entry is S. AA's substring beginning from 2 and ending at 4 is the substring SFB, 2 until 4 substring. So we can have matrices of strings as well, string objects as well. So A is a matrix whose one element is string A. It's of dimension 1, 1, 1, 2 is defined to be the string object 1, 2, 2. A21 is defined this way and A22 is that way. So that A is this matrix of string objects. If this is used, this is the syntax, A with a space, then this becomes a 1 by 2 dimensional object. It cannot be assigned to a single space in the A matrix. So it has more non-singleton RHS dimensions than non-singleton subscripts. So which is why this A and space object cannot be assigned to a single space in the A matrix. String concatenation. So if M and N are 2 strings defined this way, then putting them together in a single matrix notation concatenates the corresponding string entries. So QWER gets added to TYUI, giving you a longer string, QWER TYUI. Let's look at some MATLAB functions. The rand function produces the random matrix of size 2 by 2 here, but the max of D, the max command on D, returns the maximum entry in each column. So max of D in each column, the maximum entries are here, and min D returns the minimum entry in each column. So these are the max and min row vectors returned by the max and min commands on the D matrix. If M is defined to be this vector, then the max command invoked in this syntax returns the maximum entry of A as well as the location where the maximum occurs in M. So the maximum occurs at location 3 and the max value is A here. Likewise, in the same syntax, if the min command is used, then the min value and the location are both returned to the corresponding variables on the left hand side. So disp is short for display. So this displays the string which is inside the argument for the disp command. So how are things is the argument to disp, which is a string, and it directly gets displayed. The command string to number converts a string object into number. The 1 is a string here in this argument. It becomes 1, a number. And the reverse is possible by using the num to string command. So if a number or object is given to num to string command, what comes out of it is a string object. This 43, which has come out of num to string, is actually a string. Even though it looks like a number, it's a string actually. So the command factorial computes the factorial of numbers. So factorial 10 is a large number. For extremely large numbers, factorial function returns the approximate value as shown here.